I'm Ellie McKeown, and you're watching my Girl Scout Gold Award channel. In all seriousness, I'm here today to show you how to switch adapt an electronics children's toy with a battery interrupter. Now, before we get to that, you might be going, wait, what's a battery interrupter? What's switch adapting? Why am I watching this? I'll tell you. Switch adapting is taking something electronic and making it accessible to people with motor disabilities. For example, taking a toy and rewiring it so it can lead to a larger switch. Things like this fan weren't made with people with disabilities in mind. The original on-off switch is so small you have to use your nail to operate it. This toy does not fit the definition of universal design. Universal design is a concept that means every toy and facility was made with every ability in mind. There's a second problem when it comes to this fan. You might be thinking, so what? I'm sure you can buy a switch-adapted fan online somewhere. The internet's pretty much got everything. If we have a fan we want to adapt, and we bought it for $7, the switch-adapted version can cost upwards of $56. If you need another example, this baby Einstein toy costs $9, but when switch-adapted, costs $52. Okay, so hopefully now you're thinking, that's terrible. What can I do to help? I'm so glad you asked. You can make a battery interrupter and donate it to a local school that needs it. This is an example of a normal circuit. And this is an example of a circuit with a battery interrupter. What a battery interrupter does is interrupt the flow of energy from the battery to the toy and redirect it to an external switch. As you can see, this plate goes between the toy and the battery, working to interrupt the flow of charge and redirect it to a larger switch outside of the toy. This connects into the joy switch, and now the toy works without using the smaller on-off switch and is now accessible. Okay, now that you want to help, here's how to make a battery interrupter. Let's start with the materials you'll need. We have copper tape, double-sided wire, a free-hanging AT jack, a piece of plastic that can be taken from any old Tupperware container, and 2 different sizes of heat shrink tubing. You'll also need a soldering iron, some solder, a workstation, mine is just tinfoil on cardboard, which you can do anywhere, a lighter, and some wire cutters and strippers. First, we're going to start with the wire. Take the wire with your nail in between the two and slowly separate that so you've just got 2 free wires. Okay? Now we're going to take the first 1/4 inch off with our wire strippers on. You just take that after you've stripped them, hold them, and twist. And you've got 2 wires. Next, we're going to take our little piece of Tupperware and our 2 strips of copper tape, and we're going to completely cover this piece. You can have white on the edges, but not between the line. Next, take your scissors and cut the edges off. So what should happen is there's no white anywhere on any side of this piece. That's important because this keeps it insulated so that the charge comes in one way, does not keep going through, and instead goes up and back over. So there's your copper tape. Next, take your wire cutters and cut off just enough so that it just barely fits over the piece of tape. We want it to be very small, about that size, so it's only a little bit fits on. So it should be that small to fit onto here. Now, also, with this piece of copper, it's going to be our little backing that fits between the battery and the piece. You might notice that I made this extremely big, and yes, it is pretty big for most projects. What you want to do is cut it down yourself to fit the size of the battery you're making. If you're donating it and you don't know what toy it's going to be used for, leave it big like this, so that way it can be cut down and used for any toy. Turn on the soldering iron. I usually keep mine at about 400 degrees. Be very careful with this iron. If you touch the metal end, it's an instant burn. Take the solder in the other hand and test the iron until it is fully on. Now, tin the wires.
What that means is we'll completely coat the wire with the metal. Hold the solder over the wire and use the soldering iron to heat it up. The next step is to hold the solder over the end of the copper square and leave a small lump of solder on the end. Flip the copper square over and do the same exact thing on the other side. The next step is crucial. We're going to take this, put it right on here, and hold the soldering iron over it until it melts, and then it completes the circuit, which is pretty important. Next one. Important tip before you do anything else, take your heat shrink tubing and slide it all the way down to where the copper plate is. Then take your lighter and heat up the heat shrink tubing so that it shrinks around the wire and acts as strength relief. So this is the parts of an AT jack. So we've got one terminal here, a big bottom long terminal right here, and a second one. This is how we're going to combine them. So you know how you've got your one short one and your one long one? These are the lengths they should be at. This short one's going to solder onto this terminal here, okay? And this long one's going to lay across the bottom here. So that's how it's going to look connected when we solder them all. You don't want to connect anything to this terminal. You want to leave that completely gone because otherwise the whole thing will be shorted. And then after that we're going to cover that on up and it works. But before we get to anything like that, what you want to do is take your cover. This is what came from the AT jack. This is what it looks together. This is what it looks apart. You take your cover and you're going to slide it over the ends there. And we're just going to let it hang there. And we're going to take this really big piece of heat shrink tubing. We're going to put it on the really big bit of exposed wire. A little more. Then we're going to take the really small bit of tubing. We're going to put it on the really small wire. Easy to remember, right? Big, big, small, small. Perfect. Next step is to tin the wires again. Now we're going to tin the terminals. Hold the soldering iron to both the wires and the terminals and wait until they melt together. Now, pull both heat shrink tubes over the wire and heat them. Then add the sleeve. And that's it. You've made your own battery interrupter. From the AT jack all the way down to the copper plate. This is what it should look like. So that's all there is to it. I'm Ellie McKeown, and you're helping make the world a better place. Thank you for watching.